Hello, hi guys. Thank you. So first of all, thank you for coming. Hopefully I will not bore you to death after lunch. So it's a session that obviously we want to engage you more into it. So we're going to discuss and go through a presentation where how we at Betson, we managed to achieve global reach vis-a-vis the infrastructure and the platform that we have running on-prem. So the objective of this presentation obviously is to go through those challenges, how we managed to extend our infrastructure, especially the edge layer, right? So the edge layer is what we define as the entry point of a customer's request. So that is where we describe the edge layer and the challenges that we had to move that platform from completely on-prem to be a distributed platform. So if we go a bit through the infrastructure layer, right? The infrastructure has obviously been serving a lot of businesses for a very long time, and it has been doing a great job. But obviously it has some limitations when the business scales and the market is further away as much as possible from your location. So the infrastructure as is running in on-prem obviously has the inability and inefficiency to scale, right? Scale takes a lot of time. There is high lead times to get the hardware, high lead times to set it up. The return of investment, obviously, you need to plan advance with capacity. The content delivery throughout your infrastructure vis-a-vis on-prem is very lacking because every request needs to reach your infrastructure and you need to serve it from there. The caching capabilities are a bit limited, so you can't provide any content closer to the customer. And the operational overhead is increasing by the scale that you have on the business. So, we have this saying in Malta that obviously we believe that Malta is the center of the universe and the world, right? So this is not an actual map of the world, as one can see. Malta actually is here, right? And it's very, very small. But obviously, putting this in perspective, it gives us some data to digest, right? So as you can see here, if we have a market that has expanded in Sao Paulo, in the Latin region, okay, a customer's request to reach us, to Malta, takes us around 200 milliseconds, right? Same thing for North Virginia, Frankfurt, Central Europe, and Stockholm, Scandinavia. So all of these latency metrics gives us the possibility that we need to identify where we need to improve, right? Everything that has this type of latency will create a problem. So page content, page speed, delivery of download, SSL offloading, everything that goes around the request, all those metrics will be affected. So that's decided that we need obviously to improve this, and we had to look into how we want to do it and what are the KPIs that we want to improve, right? So first of all, obviously we wanted to have a global scalability. We wanted to reach out the furthest parts of the world as much as possible. So we wanted to have global scalability with low latency, right? So the 200 milliseconds for a customer request to reach us, do the SSL offloading, try to get the time to first byte and everything. We want to reduce that time, okay? So that is one of the most important things that we wanted to achieve. We wanted to enhance the caching capabilities. So we don't want those requests reaching Malta. We wanted to have a functionality that we can serve as much as possible data closer to the customer. The site speed improvements obviously will translate to whatever we're going to do with cache, and latency improvements will translate with site speed improvements, time to first byte, one of them, and the SSL offloading. So it's the initiation of a connection, okay? And obviously the cost. You don't want to have to move from on-prem, which obviously has its cost associated with move to the cloud, and then you have a high budget that is being consumed by all these services, and then business say like, you know what, let's go back to on-prem, and we keep on playing this game back and forth. So obviously we wanted to have a model that is pay per execution model for us. We didn't want to commit upfront, we wanted to pay for what we're consuming, because that is something that we believe we can control in a way. And no need for new infrastructure to be managed and to be provisioned for us. So those were the items that we were looking for to improve our posture when it comes to the edge. Once we did the evaluation of a vendor, we selected AWS as our main partner in this journey. And these are some of the services that we have introduced as part of this journey. So one of the things that we needed to do is we want to integrate all of this in a one huge ecosystem. So we had to start by first moving all our DNS components into AWS. So that will start giving us functionalities that we can do certificate management, auto renewals, association of certificates, and all that stuff combined together in one ecosystem. The components that we will go through mainly in this presentation are Advanced Shield WAF, CDN, and Lambda Edge. Okay? So what is CloudFront? CloudFront is the content delivery network from AWS. It has around 400 plus edge locations and POPs. Basically, a POP is a point of presence where the request of a customer reaches its ingress point. So that is where a request comes in. And that is where all the connection KPIs start to trigger. So the SSL offload is done there. If there's a cache, you save it. If there's no cache, you go to the origin. All of that is being done there. Okay? And we are able to start including functionalities where we do detection. So detection not from a security perspective, but from a functional perspective. So what's the device type, what's the country, which state of the country is that, the OS of the device. So you can start having all this content, and you can enrich your requests to reach the backend. Plus, you can use those headers to even enhance your caching capabilities. Okay, so we can serve content differently for a country vis-a-vis another country or a state. So, going through WAF and Shield. So Shield is the DDoS protection that goes on top of CloudFront, and it is a fully managed service. So you just enable it, integrates, you control it, and you integrate it with your WAF, and your WAF, you start creating your rules. So these functionalities were introduced on top of our CDN. The WAF functionality has given us a lot of benefits when it comes to common exploits, SQL injection, cross-site scripting, rate limiting, bot detection, all of that. We enabled it and we controlled it even with the new functionalities that they're introducing with AI now. So those are all available there. But most importantly is that the customization is available for us. So we can granularly create new rules that fit our need as a business partner. If we compare a bit what we've achieved with this high level, right? We have moved from a high latency solution to a low latency solution. Okay? We moved from a zero cache perspective because every request still needs to reach the origin, in case that is Malta. And we moved to a 98% cache hit ratio on all our assets. Okay? So that is less bandwidth consumed even to reach Malta, and whoever is included any cost allocation or capacity for bandwidth, it's quite high. We increased the metrics for site speed, so that is obviously an achievement that we wanted to have. And we moved from a slow and slower to scale solution to a distributed, high scalable solution. So these are the gains that we've done, and this is how the map has changed now. Again, Malta is still not the center of the world, but now we have all those locations that are bubbled there where all our data is being served. Okay? That means that any data that has not hit the cache will only reach the origin. And that is a huge difference when it comes to bandwidth and performance. Serving all those connections and all that data through those POPs will not just reduce the bandwidth allocation, but even the loads on our APIs, our backend servers, and everything that normally serves a connection. Okay, so just a bit of stats. So this is the last 6 months. So during the last 6 months, whoever follows sports, we had the Euros and we had Copa America as well, right? As Betson Group, we're both into those markets, and we had a lot of traffic. So just to give some data, we had 77 billion requests that have reached our systems, okay? Out of which we allowed only 59.7%. And when we say 59.7%, that is 46 billion requests that has gone through, okay? The other 31 billion requests, they were all blocked. And they were blocked for different reasons. If it's bot, if it's a text, if it's malicious injection requests, they have been all blocked. Apart from that, then we had, on top of those attacks, another 329 triggered DDoS attacks. So normally Shield gets triggered on volumetric attacks before WAF kicks in. We had 98.5 successful mitigation without impact, but we had 1.5 mitigated attacks which triggered some performance issues on our platform. Okay? Obviously, that 1.5% is what we are mainly after, because we want to reduce that percentage further down. Now, something that gives us more benefits when using cloud services vis-a-vis on-prem is the edge functions. Okay? So edge functions, they are all located within every of those bubbles there. So so the edge functions that we have available from AWS, they're Lambda at edge. They're not the same as Lambda serverless, right? There's a distinction between them. Lambda serverless is running specifically for that region, and Lambda serverless is running globally, which does not even need, it's not even slow start as Lambda serverless. So it's faster to start up, and it's highly scalable. Okay? Obviously, there is a difference in resource limits, so you cannot just introduce code in your Lambda edge and you expect it to run as normally it would run on serverless or a normal deployment. There is KPIs, metrics, especially not KPIs, that you need to look at, so memory usage, execution time, and optimization of code. So those are important that you need to look at. This is how Lambda is triggered and available in AWS. So you have 4 entry points that you can trigger a Lambda function. Okay? So you have the viewer request. That is where a user request first goes in, and that is where you can start interacting with the actual request. So here you can do a lot of things. You can start enriching your data, you can modify your data, you can strip your data, you can add headers on top of it, coming from WAF, coming from detection headers from CloudFront itself. You can start interacting with all these headers. And this is where you can start gaining more cache hit ratio throughout your process. So the request goes in, you modify whatever you want to modify, it goes to CloudFront, you either cache it or you don't, and then it goes to another trigger point, which is the origin request. And it does the same thing when the request is going out from the server to reach the client as a response. So, some use cases that we've used Lambda for. So we have the dynamic origins conditions. So within Lambda code, we are able to say, like, this request is coming in, but because of these conditions that I have in my Lambda function, I'm going to change the actual origin. So the origin is not going to be the same one that is configured, but I'm going to create a new connection, and I will take this request somewhere else. And this has given us a lot of functionality for us to migrate workloads from on-prem to cloud, and even from cloud to other regions in the cloud. It has given us huge value in order to do this, right? Because we enable the development teams to do this type of migration while we can control where we want to send traffic. HTTP enrichment. So, as I said, all the headers that are being detected and are being created through our edge layer, we are adding that to our HTTP request. We are translating those headers into headers that we are more friendly about. So we create that, we try not to create that vendor locking at the backend service. So our public-facing APIs, they don't know what's in front of them as a CDN. But they only know that they should receive a header that is dictating what the device is, or what the country is, okay? So we abstracted that, and we manipulated those headers through the Lambda function. We introduced services as well directly at the edge. So one of the Lambda functions that we have that is running there, when it detects that there is an image, it changes the image and it optimizes its format. So I don't know if you get an image that you wanted to have a certain profile and size, and you are requesting it as a JPEG. So we go through this Lambda function, it fetches the image, it resizes the image, and we provide it to the customer with the best format that the browser supports. Okay, so we have enhanced the way we deliver content, so we try to provide the content in the best and more optimized way to do it. We introduced as well the functionality of compliance. Okay, so we have multiple brands at Betson Group, we have multiple jurisdictions, multiple markets, we are operating in a lot of regulated markets, and some of these regulations come up with a compliance where they say traffic from that certain country should not be allowed, or it should be, you should provide a blocked page with this type of content, this type of message. So we introduced that layer to the edge, so all the requests coming in from different countries hit that Lambda function through our CloudFront, and you generate the content. You either provide the page, you either provide the redirect, or you just block the request directly. All of this has given us a lot of flexibility for us to manage even the HTTP request. So all of that combined, we are able to enrich this data, serve it to backend, and then backend can do its logic based on this data. So this is an initial architecture that we had. It's very simple. We started off with CloudFront, added WAF and Shield, and the main target was distribution, scale, and caching. Okay? This was the main target for this initial architecture, and then we started adding and emphasizing more about security. That architecture obviously evolved. Okay, by time it evolved, and we have this type of architecture. Again, obviously, I couldn't just put all the configurations that we have in CloudFront. Okay, just to give you an example, CloudFront configuration, within its configuration there is almost around 35 behaviors. Those behaviors can be, it's an API, it's an integration to a third party through the same domain, something that we couldn't do before on-prem, so that now we are able. So basically, if I say affiliates at testdomain.com, right, that affiliates, now I can reroute it directly through my configuration to a third-party platform, and that is using seamless domain. So with this type of architecture, we have been enabled to do all of those functionalities that we had at the edge, and we can reutilize them on how we want to pass our traffic. So for example, if you look at the routed DNS there, that means that we have an origin that we have workload in Malta and Frankfurt. But we can choose where we want to move that traffic. We can do it either by latency policies, or we can even do it by weighted policies. So if I want to do a migration, now I'm enabled to do it seamlessly without my configuration being touched. On the other hand, then we have the Lambda dynamic selection, another function that we have in the code, where we can, by the conditions mentioned before, dictate which origin to use. And that origin is not even part of the configuration, but it's dynamic. So it's generated on the fly, you connect to that origin, you send the request, you come in, you close the connection. And the connectivity for the edge services that I explained before, related to the image API, for example. That is something that is completely, so this part there, is completely managed in here. So any request that is coming from anywhere in the world, that service is being triggered. So it doesn't need to reach the origin. It's handled directly there. So obviously, this type of architecture constantly evolves. So especially the security part of it constantly evolves. New attacks. There has been a lot of emphasis about AI in the morning. It's obviously it's there. And the type of attacks that are being created through AI now, they are more sophisticated than they were before. Okay, so obviously that is the continuous improvement that we're doing. We're looking constantly at what the data is doing. We're ingesting ourselves data to some AI models so we can generate more and more information, and we keep on improving on our WAF rules and our CDN configuration. Okay, Lambda, again, it's something that you constantly need to go through it. You have to make sure that your code is updated, optimized, and your runtime is running properly. So that is a constantly improving process. We have a team dedicated for this. We have a DevSecOps role as well, who's integrated to that team that constantly goes through all of this. So, key considerations when moving such a journey, in our opinion. Integration to your current infrastructure. So it's something that we had to give a lot of importance. We didn't want to move to a platform that we could not integrate seamlessly if we want to move to it. So for example, AWS for us was a good option because we knew that we're going to move even our backend. So all of those POPs that were seen in the map before, when we moved our front-facing APIs and our front end, the connection between a POP and the origin goes through an optimized path. It doesn't go over the internet. Goes through an optimized path, which gives us less latency to handle, okay, and makes the connections faster. Cost and budgeting, very important. Anyone who's on a cloud journey and does some FinOps, they know that there is a lot of cost, and if you're not aware of that cost, it can skyrocket quite easily. Okay, so services in compliant and regulated markets. We had issues with certain regulations where they did not accept that our content is served through the edge, through this type of edge. Some of them we managed to convince, some of them we didn't manage to convince. So that is where you have to fall back completely to your on-prem solution. And performance monitoring and optimizations. Obviously, it's very important. If you want to do something, you need to measure it, and you need to showcase how you improved it. Or if you're doing a change, you need to make sure that you did not degrade your performance. So those are considerations that obviously anyone should keep in mind. Now, obviously, how do we manage this? There's all of those resources, they take a lot of effort to maintain, right? And then, if you're a company like Betson, we have 25 or 26 brands or sites that are using this type of architecture, and obviously they are all managed differently. Managed differently in terms of isolation. So for every resource that we create, there is 25 others. So each brand has its own resources. So obviously, how do we manage that? Doing it manually, clicking on the UI doesn't really do it anymore. It's too cumbersome, takes a lot of time, human errors, everything. So everything that is related to how we manage infrastructure is moved to code. Our go-to framework here is Terraform. So we manage everything in Terraform, everything is in Git. All the states are in our cloud provider as remote states. Pipelining for Terraform, it's not the easiest thing to do, but we're getting there. So we want to introduce TF-lint, TF-sec, all of the policies that you can introduce, so you'll start to reduce as much as possible your impact when you do changes, because obviously there is a transition, right? So you have your traditional sysadmins, traditional network administrators. Now you're moving them to more of a GitOps approach. So there are those challenges as well, but everything is in code. It is reproducible and it is maintainable. So just a recap on what we've discussed and what we've gained with all of this. Okay? So we went from, again, a high latency approach to a low latency approach, global networking, scalable. We achieved higher caching vis-a-vis the on-prem solutions. Security, drastic improvement. If you look at, going back to that slide about the DDOS and the WAF, that's not even close to what we used to sustain before we moved to the edge. I mean, before moving to the edge, we had like 2 or 3 outages a week with DDoSes. Something to mention as well, the previous session that was done by Invicti, I think it's Invicti, yeah. They mentioned the Microtic exploit, right? Just last month, that Microtic endpoint hit us really bad. So we had several attacks coming from the Microtic network. Just to give you an example, it was around bursts of attacks of 5 million requests every 5 minutes. Okay, so what they were talking about, it gave me a bit of goosebumps. So, but it was mitigated, and in fact, that 1.5% something of impact was related to some of those attacks. So it is very important that you have a security platform on top of your edge that can scale and sustain that amount of requests. So that's all from my end. If you have any questions. Okay. Yeah.
Yeah, so you had mentioned, obviously you mentioned you use Lambda at Edge and you use Terraform to manage the infrastructure and code stuff, right? But I was wondering, the scripts you actually write and deploy into the Lambda function, right? Like, how do you manage that? And like, how about the pipeline for that?
Yes, so to manage the Lambda code itself, it's still in Terraform, right? So you build your Lambda code. In our case, it's written in Node. You build that Lambda code, you have a pipeline that you go through the linting process of it and all the tests that you want to do for that particular code. And when you generate it, it is in Terraform. Terraform is not going to deploy it in that state, right? So Terraform then picks up that file, generates a Lambda resource, it injects that file in that Lambda, zips it, and sends it over through the API. That is where you generate a new version of your Lambda code, and then you apply that new version to your CloudFront configuration.
Okay, so you do have to run the Terraform scripts.
Yes, it's still managed through Terraform. Yes. That is a difference between Lambda and Lambda serverless. Lambda serverless gives you the ability that you connect directly to the Lambda portal, and you can do rollouts of your Lambda. Lambda serverless has only enabled the sort of AB rollout just a couple of months ago, and that is something that we're gonna start investigating how to integrate it as well. But again, once you deploy it and something is wrong, you just go into your code, you change the version of your Lambda, so you roll back and you reapply again. So it's a fix forward for a rollback. Okay.
Also, the WAF thing, I don't know if you use the rate
Yes, we do.
And in our experience, I think we realized that it's a little bit, what's the word? Limited. Do you have, I don't know, have you experienced that limitation, and do you have any solutions?
Yes. So, I agree, it was quite limiting, but I'm not sure if you're aware of the new functionality of it. So they've changed the rate limiting that they have. So basically, and we've actually implemented that new rate limiting. So the rate limiting that has been changed now, it was 200 requests as minimum through a 5-minute period. Right now that is flexible. So we can go down to, I think, 50 requests, and you can have the baseline of 1 minute. So what we've seen with the Democratic attack, it was so spiked as attack that 5 minute we were being allowed to have a lot of traffic coming into our platform. So we, on top of the rate limiting that we had, we added an extra rate limiting rule where we moved down the baseline to 2 minutes, and we reduced the amount of requests that can go through to 100. And that was triggering a couple of seconds before the actual rate limiting was triggering. So from that point of view, it has removed some of its limitations. Yeah, I'm not sure if there was someone there first.
I was curious. Key takeaways. Why AWS versus, for example, Azure or OCI?
Well, a good question. So the idea is that I'm responding in English actually. When we started looking at different vendors for this, the idea was that we've seen Azure, AWS more mature in certain resources that were more specific to us. So for example, here obviously we didn't go through what architecture we have, but mentioning it, we have quite an advanced way of how to do routing. So there is some complexities that we added in AWS which are not able to be supported in Azure for us, where we said like, okay, this is, we can't do it. So when we started doing at the edge, we were already thinking about how we can leverage on using other stuff in AWS. And for us, that was one of the key takeaways why AWS should be used. But it's obviously it's our use case. It's not. So.
Yeah, I want to ask, do you have any data lake where you are collecting all the information, all the DDoS attack information coming across all different brands, and connected at the end of the day to the WAF technology that would try to mitigate and find pattern across different attacks, across different brand times, IP, whatever it is?
Yes, so as I said, we have around 25, 26 brands. So all of them have different markets, different way of how to handle or promote content. But we have opted to go for one single WAF rule, WAF ACL. Yes. So the idea is that the ACL itself learns a lot when you have a lot of traffic coming in, right? But the key takeaway is that your backend, or your front end in this case, so it's the front end and the APIs, they need to be the same, right? So if you have multiple flavors of your front end, multiple APIs that are not being used in the same distributions, then it would be not beneficial for you to use a single ACL. In our case, since our sites are very similar to each other, right, we introduce the same ACL, so the ACL learns a lot on its own. So when we have the shield connected to layer 7 WAF mitigation, that learning is across all the brands. So that is one of the things how we do it. Then we still collect all the WAF logs into OpenSearch, and that is where we're starting to do some of the data analysis there to enhance more the capabilities of WAF. At the moment, we don't have an automated way to analyze that data and suggest mitigations. But that is where we're heading with the mitigation process. So that's our aim now. So now we have a good stable platform. Now we want to start automating that improvement.
Thanks.
Any other question?
Another question from us. You mentioned that some clients would want to reach the cloud version because of sensitivity. Maybe they don't want to store or submit some sensitive information on the cloud.
No, what I was referring is the compliance part. Right? So basically you'll have, so if I have a brand that is test.com, right, but it's only regulated in 6 markets. Obviously that brand is on the internet, right, it's publicly available. We don't do whitelisting of countries on the brands. We actually do the contrary, we just do blacklisting of countries. Okay? So if a brand is reaching another jurisdiction that we have another site that is compliant in that jurisdiction, they would want us to block users from accessing that site, right? So when the request originates from a country and hitting a brand, we have a logic, a map, say like, oh, this brand for this country. If it matches, then we provide you either with a redirect or with a page that says like, you cannot play this on this site because of compliance issues. But it's not because of sensitive data. Having said that, we still have other compliance requirements that goes through the actual site and APIs. So that is where the more robust logic is for compliance. But at least we try to reduce as much as possible customers reaching sites which are not in a compliance region. Any other question? Last one? No? Okay. Thank you.